In general, we have two options for an equation. That equation is either dimensionally compatible, meaning that every single term in the equation has the same dimensions, or that equation is non-dimensional. Meaning that every single term in the equation is dimensionless. There are equations that disobey this general rule of dimensional compatibility, but we're not going to encounter them in this class. The assumption of dimensional compatibility is how we're able to say, okay, well, n is on both sides of the equation, and so whatever its dimensions are population, that doesn't really matter. But time is just on this side, and so this side of the equation has dimensions of p over t, and that needs to be equal to the other side of the equation having dimensions of p over t. So this idea of dimensional compatibility is how we're able to infer the dimensions of R. What do we want to do once we have these dimensions? Well, in general, the non-dimensional version of an equation is a preferable thing to analyze to the dimensional version of the equation. And so we're going to use these units to help us non-dimensionalize the equation. Why do we want to non-dimensionalize? One reason is that the process of non-dimensionalizing is going to get rid of some of our parameters, and so our equation will become easier to analyze because it will have fewer parameters. So to find a dimensionless product, the only units that show up are p and t. So a dimensionless product of these variables would have units of p to the 0, t to the 0, meaning that neither p nor t is actually showing up. So we're going to look for dimensionless products, and they're going to be of the form n to the a, t to the b, r to the c. And so that has units of p to the a, t to the b, t to the negative c. And we want this to be equal to p to the 0, t to the 0. So the first thing we should do is simplify and combine. So this is p to the a, t to the b minus c is equal to p to the 0, t to the 0, and we can set up a system of equations. That system will be a equals 0, b minus c equals 0. It's unclear what to do with this a equals 0. I guess it's basically saying that n is dimensional and there's no obvious way to non-dimensionalize it. And then it's pretty clear what to do with this b minus c equals 0. That's saying that b equals c, so RT is dimensionless. So we have like a non-dimensional product associated with t, but we haven't been able to deal with n yet. And to deal with n, I'm just going to invent n naught equals population at time 0. N over n naught is dimensionless. Now, actually, I'm going to non-dimensionalize the equation. So I'm going to let x equal n over n naught, and I'm going to let tau equal RT. And so to non-dimensionalize this equation, I'm going to maybe substitute. So n equals x n naught, t equals tau over r. I can just substitute x n naught in every time there's an n, and tau over r in every time there's a t. That results in this equation, d x n naught over d tau over r is equal to r x and not, these and not cancel, and I need to do a little more manipulation. So I pull out the 1 over r from inside the derivative because it's just a constant. So d tau over r is d tau times 1 over r. So we have dx d tau times 1 over r is equal to r, but 1 over r is actually just r, and so these cancel as well, and we get the equation dx d tau equals x, which we will write as x dot equals x. So this is a non-dimensional version of this originally dimensional equation. How can we tell it's non-dimensional? Well, this side, if it were dimensional, would have units of x over t, and this side would have units of whatever x is, and those don't match up because there's a 1 over t on this side, and there's no time at all on this side. So the only way that this equation can make sense is if it's already been non-dimensionalized. What makes this equation nicer? Well, there's no parameter anymore, so we know that whatever this parameter was doing, its only effect was as a scaling factor on the time scale on which processes happened. So whatever solutions of this look like, solutions to this thing look just like solutions to this non-dimensional thing, just time is scaled by some number, and population is scaled by some number. So this non-dimensional equation will give us the correct shape of the solutions, and then if we want to go back to dimensional form, all we have to do is scale those by some dimensional numbers.